Chapter 11 is probability and statistics. Big ideas here have to do with probability and data collection and analysis. The first thing with probability is what is the difference between a permutation and a combination? The second thing having to do with probability, what is the difference between experimental and theoretical probability? And the last one has to do with data collection and analysis. How are measures of central tendency different from standard deviation? We're not going to get into that one as much. Measures of central tendency are like mean, median, and mode. They're different ways to talk about the middle of a group of data. The standard deviation tells you how far away from the middle you are. So that's the difference there. And we'll get into more about the probability, less about measures of central tendency in the amount of the chapter that we're going to do. So section 11.1 here is permutations and combinations. I can count permutations and I can count combinations. Big idea here, multiplication can be used to count the number of ways that certain things can happen. The fundamental counting principle describes the method of using multiplication to count. So the take note on page 674 is our fundamental counting principle. It says, if event M can occur in M ways, and is followed by event capital N that can occur in N ways, then event capital M followed by event capital N can occur in M times N ways. So it's a lot of stuff there. A lot of maybe this, maybe that. Here's an example. If we have 3 pairs of pants and 2 shirts, okay, we can take 3 times 2 to get 6 possible outfits. Okay, so if you're looking in your closet and you're looking at 3 pairs of pants and 2 shirts, there's 6 possible outfits that you can wear based off the combination of those. Example 1 is using the fundamental counting principle. The photos on page 675 show Maryland license plates in 2004 and 1912. How many more 2004 style plates were possible than 1912 style plates? So if we look here, in the first one, the 2004, we have a letter, and then a letter, and a letter, and then a number, a number, a number. Okay, in the 1912 style, we had number, 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 number. So to find our counting, using the counting principle here, we take how many times they can occur and multiply them. There are 26 letters in the alphabet, so 26 options for our first letter, times 26 letters for the second, times 26 letters for the third. There are 10 digits, 0 through 9, so 10 options there for the number parts. Okay, if we take 26 times 26 times 26 times 10 times 10 times 10, we get 17,576,000 options, and this is 2004. In 1912, each number had 10 options, so we multiply 10 times 10 times 10 times 10. Again, it could have been 0 through 9 for each one of those options. So we take 10 times 10 times 10 times 10, and we get 10,000. And this was the 1912. We want to know how many more were there. So here we can subtract. Okay, we can take 17,576,000 minus 10,000 and get 17,566,000 more options. So that's part of the reason that we see letters on license plates, is because it gives us more options. We have 26 different options for each spot with a letter versus 10 options for each spot with a number. Okay. Now, in 1966, one type of Maryland license plate had 2 letters followed by 4 digits. So it was a letter, and 4 numbers. How many types of license plates were possible? We have 26 possible letters, A to Z. So we're going to multiply those. Numbers, we have 10, 0 to 9. And we multiply all of our options here. So counting principle says we multiply each event. So 26 times 26 times 10 times 10 times 10 times 10, which is going to give us 6,760,000. Okay, possibilities. Which is better than 1912, not as good as 2004. And in some places like Maryland or New York or California, where they have significantly more vehicles, like in North Dakota, not such a big deal. We don't have enough people to have enough vehicles to make it matter. But when you get into more populated places, it does start to be important, which is why sometimes you'll see them have different style of plates as well, to help counter that a little bit too. A permutation is an arrangement of items in a particular order. Okay, permutation, particular order. Order matters. Suppose we want to find the number of ways to order 3 items. There are 3 ways to choose the first item, 2 ways to choose the second item, and 1 way to choose the third item. If we use the fundamental counting principle, there are 3, 2, and 1, which gives us 6 permutations. So if I have a circle, a triangle, and a square, okay, I can pick each one of them to go first, which gives me 3 options. But let's say I pick the square to go first. That only leaves me 2 options for my second shape. Now let's say I pick the triangle. That only leaves me 1 option for my third. And that's what they're getting at there, as far as 3 ways to choose the first, 2 ways to choose the second, and 1 way to choose the third. Now, there's still going to be 6 ways that we choose these based on our fundamental counting principle, but the order here matters. We can use factorial notation to write 3 times 2 times 1. And factorial notation is 3 with an exclamation, and we just say 3 factorial. Okay, n factorial, and I have this up on my wall at the edge of my bulletin board by my I squared equals -1 factorial. Factorial means we take that number, so n factorial is n, and we multiply by the number before it, times the number before it, times the number before it, until we get to 1. So 6 factorial is 6 times the number before it, 5, times 4, times 3, times 2, times 1. Okay? 0 factorial is 1, so something to think about there. How many ways can we file 12 folders, one after another, in a drawer? This is a permutation because the order matters here. It doesn't particularly matter which order we put them in, but once we put a file in, we can't use that one again. So here, it's going to be 12 times 11 times 10, okay, are options that are left. 12 factorial. So rather than taking 12 times 11 times 10 times 9 times 8 times 7 on your calculator, what we can do is we can use the factorial button. And on those of you that have TI-30 pluses, like the ones up on the poster in my room, we're going to use that PRB key, which is kitty corner from the second key. It's where we switch a fraction to a decimal. We're not going to press second, though. It's right above your fraction key, PRB for probability. So we're going to type in 12. Then we're going to press our PRB key. And we're going to go over twice to where it has our factorial. Then press enter. And enter again. We should get 479,001,600. So if we have 12 folders, there are 479 million ways we can order those. Okay? And again, this is the keystrokes. 12 PRB key, which again is on your calculator, you have second key, degrees, radians, gradient, your log key, and your PRB key. That's the key we're looking for. And this is up in the, like, here's your screen, and here's the edge of your calculator. TI30X. If you have a different type of calculator and can't find it, we can look at it in class. The arrow keys that I was talking about right here are this key right here. And we want this one to go over. Okay? How many ways can we arrange 8 shirts on hangers in a closet? Okay, there's 8 ways we could pick our first shirt, 7 ways we could pick our second, 6 shirts left for the next option, then 5, then 4, all the way until we only have 1 shirt left. And so we're going to take 8 factorial. Again, 8, PRB, shift over twice, press enter, and enter again. And we're going to get 40,320. If we don't have that key available, if you can't find it on your calculator, we can just multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I got to the same place. It's more time consuming, but until we find that key, that is an option. And I will stop this video here and start example 3 on the next one.